Okay, it's time for the old Unit 2 review ski, okay? The first problem's our cakewalk, okay? So you got 3/16 equals question mark over 256. You can cross multiply and divide. That'll give you the answer. Or you can say, okay, 16 times what's 256? So it'd be 16. 3 times 16 is 48. Okay, number 2, 7 over 12 equals question mark over 36. You can cross multiply and divide, or 12 times 3 is 36, 7 times 3 is 21. 27 over 5 equals question mark over 105. 5 times 21 is 105. 27 times 21, 567. Number 4, reduce each fraction to lowest terms. If you went to a you can use ABC if you want. If you went to a multiplication chart, these are both in the 5th row, so they'd be divisible by 5, and that'd be 1/7. Okay, 8 over 12. Now they're both in the 2nd row, but further down they're both in the 4th row, so that would reduce to 2/3. Again, those are both in the 2nd row, true. They're both in the 3rd row, but they're also both in the 6th row. So that's 3/4. Okay, next one, number 7, express them as mixed, the following mixed numbers as improper fractions. 3 and 13 over 64. So your fraction has a denominator of 64. Now to find the numerator, take your whole number times the denominator and add the numerator. 3 times 64 plus 13, 205. $53 and 3/8. So I take the whole number times the bottom plus the top. 427. Okay, number 9. 2 and 8/9. 9's a denominator, so we take our whole number times the denominator plus the numerator. So it's 18, and then plus 8's 26. Okay, express the improper fraction as mixed numbers. You could ABC it, that'll give you the mixed number. You could also use long division. 4 goes into 8 twice. 4 times 2 is 8, and that's 0. I bring down the 5. 4 goes into 5 once. 4 times 1 is 4. So that's my remainder, so it'd be 21 and 1/4. Okay. 167 over 128. Due to the fact this is a public video, and I already had a video where I was using the ABC key quite frequently, so I better go. 128 goes into 167 once. Subtract 128, 17, that's a 9. So that's 3. So 39 is your remainder. Okay, so 1 and 39, 1/28. Okay, 5 goes into 22, won't go into 2, goes into 22, once, twice, 3, 4. 5 times 4 is 20, we've got a remainder of 2, so 4 and 2/5. Okay, now the next one, 13, you cannot just rely on a calculator here, okay? You need to determine the lowest common denominator of the fractions. That means that you don't do anything, you can't ABC it, okay? And just using a chart's not going to work either. You have to know how to use your factor trees. So you have a 9, a 3, a 12, and a 10. Okay, so let's talk about 9. Again, the prime factors are 2, 3, 5, 7, 11, 13, 17. They keep going, okay? But that's probably good enough. You can stop at 17. So 9's not one of those numbers, so it can be factored down. What's 3 times 3? And then 3's on here, so I circle them. Now 3 itself's prime, so I circle that. 12, definitely not a prime factor. You can go 2 times 6 or 4 times 3. It doesn't matter, okay? Now 2's a prime factor, but 6 isn't. That can be written as 2 times 3, and don't put that as 3 and 3. 3 times 3 isn't 6. Okay. All right, number 10, 2 times 5, and those are both prime. Okay, now here's how you determine this. So you have a prime factor of 3. I have 2 here, 1 here, 1 here. The greatest amount of 3's I have is the 2 from here. So 3 times 3. Now you can forget about all your 3's. Those are done. 2's, that didn't have any, that didn't have any, that had 2, that had 1. So 2 is the greatest amount. So times 2 times 2. And then 5, none, 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 1. So times by 1 factor of 5. So 9, 18, 36, and then 36 times 5 is 180. So the common denominator is 180. Okay, 14, you can use the ABC key if you want to do the operation. I will get common denominators for educational purposes. Okay, so we've got 8, 3, 5, 7. 8's not prime. 4 and 2, the 2's circled, and then 4, 2, and 2. 3's prime. Okay, 5's prime, and 7's prime. So 2's, well, that has 3 2's. 0, no 2's, no 2's, no 2's. So 3 is the greatest amount. Okay, 3's 1 3 here. 5's 1 5 and 1 7. Okay, so 840 is your lowest common denominator. Definitely that wasn't going to show up on the multiplication chart. Okay, so 8 times what's 840? I'll divide 840 by 8, 105. So we'll times the 5 by 105, and that's going to be 525. Okay, 840 divided by 3 is 280, so 1 times 280 is 280. 840 divided by 5 is 168. 2 times 168, 336. 840 divided by 7 is 120. 3 times 120 is 360. Okay, so you got 840 as your lowest common denominator. Okay, 1,501. You know what, I'm just going to ABC that, because dividing that's going to be a pain. 1 in 661 over 840. Okay, number 15. 9 and 3/8 plus 15 plus 1 and 1/2 plus 3/16. Okay, 26 and 1/16. Okay, I feel kind of slimy doing that, so I'm gonna show it the old-fashioned way. Okay, so I'm gonna add my whole numbers. 9, 15, 24 plus 1 is 25. So 25. Okay, then I have 8, 2, and 16. Okay. Okay, so the common 16 is in the 8th row and the second row. So 16 would be your lowest common denominator. So 8 times 2 is 16, 3 times 2 is 6. 2 times 8 is 16, 1 times 8 is 8. That can just be 3. So I add them, that's going to be 14, 17. And I divide 16 into 17 into 16 into 17, that's 1. With the remainder of 1. So 1 and 1/16. But remember, you had a 25 there, so 1 plus 25 is 26 and 1/16. There, I feel better about myself. Okay. 15 over 16 minus 1/3. Now, EP in class had a great comment. She says, can't you just multiply the denominators? Yeah, 16 times 3 is 48. That will work. Okay. So 16 times what's 48? It's 3. And then 15 times 3 is 45. 3 times 16, 1 times 16, and then 45 minus 16 is 29 over 48, and those are not in any row. 29 is a prime factor, so it's done. 17, 63 and 7/10 minus 37 and 29/50. Now with subtraction, you got to be careful. You're going to rewrite it. You can't subtract. Subtraction is different than addition. You can't just subtract the whole numbers and then the fractions. Okay, 10 and 50. If 50 is in 10's row, the 10th row also contains 50, so we use 50. So that'll stay 29/50 times 5 is 35. So 35 minus 29 works, that's 6/50. And then 63 minus 37 is 26. 6 and 50 are both even, so we can reduce them by 2. That's going to be 26 and 3/25. Okay, multiplication. 18, 5, 6 times 17/20 times 1/5. Okay, 5. Now, if you have a 5 and a 5, they can cancel and both become 1. 17's prime, so you pretty much can't cross out anything else. 1 times 17 times 1 is 17. 6 times 20 times 1 is 120. Okay, 4 and 4/5 times 25 times 2 and 1/16. Now, to be able to do that, you need to reverse, you need to make those improper. So 4 times 5 is 20, plus 4 is 24. 25 over 1. And then 16, that's going to be 32 plus 1 is 33. Okay, that's a 16 there. 24 and 16, those are both in the 8th row, so we can divide those by 8. So that becomes a 3, and that becomes a 2. 25 and 5 are both in the 5th row, so that's a 1, that's a 5. 33, nope. Okay, so you're done there. So 2, 1 times 1 times 2. 3 times 5 times 33, 495. Then they want it as a mixed number. 2 goes into 4 twice. 2 times 2 is 4. Minus, you get 0. You got to drop the 9. 2 goes into 9 4 times. 2 times 4 is 8. 2 goes into 15 7 times. 2 times 7 is 14. Remainder 1. So 247 and a half. Okay, number 20, 11 over 12 divided by 5 over 6. So rewrite that as times, and then 6 over 5. 6 and 12 are both in the 6th row, so they can be divided by 6. That's 1/2. It's going to be 11 times 1 is 11, 2 times 5 is 10. Then I take 10 goes into 11 once. That's remainder 1. So 1 and 1/10. Okay, number 21, 8 and 5/16 divided by 2 and 5/16. Okay, now like with multiplication, division, first we're going to rewrite these as improper fractions. Okay, 8 times 16 is 128, plus 5 is going to be 133. 32 plus 5, 2 times 16 is 32, plus 5 is 37. So now what I do is I can turn it to multiplication as long as I reciprocate the second fraction. Well, the 16s can go bye-bye. I have 133 over 37. 37 into 133, that's kind of a tough one. We'll try 3, 9. Good guess, okay. So 3, so that's 111. That's going to be 22. Nothing, so that's your remainder, so it's 3 and 22/37. Okay, last one of these. We have a big division bar, 3 and 1/4 times a parentheses 10 and 3/8. minus 4 4/7, 3 2/3. Okay, even though I'm not feeling that ambitious here, I'm going to simplify the innermost parentheses by taking 10 3/8 minus 4 4/7. Okay, 5 45, 56. Then I multiply 3 1/4. And I get 18 193 over 224. Divided by 3 2/3. I'm just going to do this on my calculator. So 18 ABC 193, ABC 224, divided by 3 2/3. Okay, second, PRB. Yeah, it's not working, so just round it. Just go 5.14. I'll accept that on the test. I don't care what they say. Okay, 23. This time I'll be using ABC. A baker mixes a batch of dough that weighs 300 pounds. The dough consists of 130 3/4 pounds of flour, 8 pounds of salt, 12 3/4 pounds of sugar, 2 3/4 pounds of malt, 6 1/2 pounds of shortening, and some water. How many pounds of water are used? So that's your total amount, and you're going to subtract from it. Now I would add then all the ones that I knew, okay? So 130 3/4 plus 8 plus 12 3/4 plus 2 3/4 plus 6 1/2, 160 3/4. You subtract that, it's going to be 139 1/4 pounds. Or you can just take 300 and minus them one by one. It doesn't matter. 24, I know some of you guys don't like these, but they're part of the curriculum. Determine dimensions of A, B, C, D, and E in the parts shown. Okay, there's other ways to do this, but here's how I'm going to do it. This is A, okay? Outside the A, we have 16 1/8. So I'm going to have to subtract something from 16 1/8. So if A is from here to here, I need to find from here to here. Oh, right there, 7 1/2. Okay, wait a second. Okay, 8 5/8. Okay, let's talk about B. Where's B? There it is, okay. All right, now I've already found my answer for A. Now you could go way outside, that's fine, but it'd be easier just to take your answer from A, 8 5/8. And this is A. B goes from here to here, so I need to find minus this and minus that. So from here to here is 3 3/16. And then this little part here, look for the arrows, there they are, 2 1/4, okay? You can't barely see it, but it's there. So 8 5/8 minus 3 3/16 minus 2 1/4, 3 3/16, that's B. Okay, C. C is a little bit tricky, okay? Here's what I would do to find it. There's other ways, okay? So you have C. I would go all the way across, okay, and take that total amount, 16 1/8, and I would subtract from that. But obviously C isn't as long as that, okay? The whole thing's 16 1/8, so I need to find out what here to here is. Now look, okay? Okay, there's 2 arrows from here to here, so minus 3 3/16. And also I need to find that amount, 3 9/32, okay? So 16 1/8 minus 3 3/16 minus 3 9/32, 9 21/32. Okay, then D. Okay, nothing much about D, so look on the other end, the parallel end, 38 23/32. and I can subtract from that. But D isn't as long as that, because D, so from here I'm going to subtract 7 and 5/16. Then also I need to subtract here to here. Now you don't see it there, keep looking. Okay, here to here, 6 and 15/16. So 38, ABC 23, ABC 32, minus 7, ABC 5, ABC 16, minus 6, ABC 15, ABC 16. 24 and 15, 30 seconds. Okay, E. E's easy, okay? No pun intended, because outside here you got 38 and 23, 30 seconds. But obviously E's just this, so I'm going to subtract all these smaller parts from the E, and that finds the remainder. So minus 9, or 9 and 39 64ths, minus 9 and 3/4, minus 6 and 15/16. Okay, that'll give you your answer. You can always start with the higher side and start minusing. Okay, 2 and 27/64. Done with that problem, thank goodness. Alright, number 25. Before starting a wiring job, an electrician takes an inventory of materials and finds that 2,500 feet of BX cable are in stock. Following lengths of cable are removed from stock for the job, and they give you 205 and 1/4, 105 and 1/3, 400 and 2/3, 108 and 2/3, 205 and 3/4 feet. Now, after they complete the job, they take 100.5 of those feet and return them to stock. How many feet of cable are in stock after completing the job? Relatively easy problem, okay? So we start with 2,500, and then we're going to remove 205 and 1/4, 105 and 1/3, 400 and 2/3, 108 and 2/3, 205 and 3/4. You can minus them one by one. You can also add them all together, and then just to subtract the sum from 2,500. Does the same thing, okay? It's really not going to be any shorter either way. Now, if I didn't have the ABC key, I would be adding them all together first, because subtracting is a pain with mixed numbers, because you have to do all the borrowing and all that. But so then I would have to subtract, but I wouldn't have to keep subtracting. Okay. That's 1/3. I mean, try the second PRB. It's 1/3. Okay. 1,474.3 repeating is 1/3. Okay, that's like a common decimal. Now you're not done, okay? Because after you're done with it, after you've subtracted all those, you're going to say, okay, I didn't need 100.5, so I'm going to add that back on to how much I have in inventory. Okay, 1,074 and 8.33. Okay, that can be written as a fraction. You can just put in it. Just go 1,575. It's good. Not really concerned if you get a decimal and have to read. Okay, now you have tables. The recipe for chicken salad sewn makes 1 serving. Okay, a chef needs to make 3.5 servings one day, 5.5 servings the next. I'm not going to do the whole thing. Okay, it's going to be a waste of your time. By the way, it shouldn't say 2542. It should say 3.5 and 5.5. So if 1 serving's 2 3/4, 3.5 servings, I just need to multiply. Okay, 2 and 3. So if you know the quantity of 1, if you have more than 1 of that quantity, you can just multiply. 2 3/4 times 3 1/2. Okay, so 9 5/8. and then 2 3/4 times 5 1/2. Now there was an assignment earlier with these type of recipes where you had to divide. Now I would divide, if that wasn't one serving, I would have to divide how much by the amount of servings, but since it's just one serving, I'm ready to multiply, because that's the rate, okay? 2 3/4 times 5 1/2, okay? 15 1/8, and then it's just repetitive, okay? So again, 2 1/4 times 3 1/2, 2 1/4 times 5 1/2, 2 times 3 1/2, 2 times 5 1/2. I'm not going to waste time going over more of that. Okay, this problem here can be a nightmare if you don't know how to read it, okay? You have this little table here, okay? I'm going to explain it because it got cut off and it doesn't make a lot of sense up there anyway unless I talk about it. You have to find the number of what are called, these are called board feet. Okay, these things are making it. So if you're going to order it, you know, how many board feet do you need? Here's a formula. T times W times L. T is how thick the board is. W is the width, okay? And then L is the length. Okay. Thickness and width are both in inches. Length is in feet. You don't have to make any conversions, okay? They go into the formula that way. Okay, first what I'm going to do is make a box here. And I got to find all the 3 by 18 board feet that I need. I need to count them. Well, how do you do that? Well, here's 3 by 18. That's for your top boards, okay? There are 1, 2, 3, 4, 5, 6 of them. Put a times 6 out there, because after we use our little formula, we need to multiply by 6. So 3 and 18 is the thickness and the width, okay? So into that formula you can put 3 times 18. Now the length of those, look around, oh, it's 6 1/2. There's 6 1/2, well, that's the length in feet, it's the long side. Then 12, okay? Now, we don't times by 6 till after we've multiplied and divided by 12. We're timesing by 6 because there's 6 different boards up there. So just one of those boards, I take 3 times 18 times 6 1/2 divided by 12, okay? Then I'm going to multiply by 6, okay? So 175 1/2 board feet. That's how that's labeled. Okay, 4 by 4. So where are the 4 by 4? There's a 4 by 4. Those are your legs. Well, everybody knows a table has 4 legs. So how many board feet do I need to order there? Okay. Well, the 4 by 4, that is your thickness, that's your width. So 4 by 4. Okay, now look, how long are the legs? Right there, 3 1/3. Okay, so I need to find the product of 4, 4, and 3 1/3. Then I divide by 12. And then after that, that's only one of the legs. There's 4 of them, so you need to times by 4. 17 7/9 board feet. Okay, C. Now this one's complicated. You're actually going to make 2 boxes. I'll explain why on the table. I shouldn't tell you that right away, but I will. 4 by 6. Now here's a problem. You have 4 by 6, 4 thickness and 6 width. You have different pieces, because here's 4 by 6. So you have here and here, that's 2. But then you have here, that's 4 by 6, and the back part's 4 by 6, so that's also 2. Now, why do we have to make 2 boxes? Why can't we just make 1 box and times it by 4? Well, because this and this are different length, okay? This and this, different length. Now, it's true you start with 4 by 6, but now look at the length of this, okay? How long is it? It's 2 1/3. Now look at the length of the longer side. That's 5 1/4. Okay, so 4 times 6 times 2 1/3 divided by 12, and then you got times by 2, okay? Go second, PRB equals, so that's 9 1/3 for that one, okay? Here, you got 4 by 6 by 5 1/4. Divide by 12, It's 10.5, and then times 2, 21. Now you have to add those. 9 plus 21 is 30, so that's 30 1/3 board feet. Now let me explain again why we're making two boxes. The 4x6, that's 4x6, and that's 4x6. Two of these, you have to do it separately because that's a length of 5 1/4. That's a length of 2 1/3. Okay, find the total number of board feet. You just add them up. Okay, 175 ABC1 ABC2 plus 17 ABC7 ABC9 plus 30 ABC1 ABC3. Okay, 223 11/18. Label is board feet. Okay, last problem. Fairly easy one. A tank shown is to be fabricated from steel plate. An engineering aide refers to a metals handbook and finds that the steel plate weighs 9.5 pounds per square foot. The weight of the tank is computed from the following formula. Find the weight of the tank. And there's your weight of the tank. So pi, 3 1/7. Okay, diameter is 4 1/3. Times 1/2, there's a diameter again, 4 1/3. Plus your length, 12 1/4. Times the width, which is, they tell us, or W is the weight per square foot, which is 9.5. Okay, parentheses, you got times and plus, you got to times first. 1/2 times holds a greater value than addition does. Okay, 14 5/12. And the rest of the outside operations is just multiplication. Okay, 1,865 is fine. And it's pounds. It's a big tank that's like really heavy. Okay, that's that.